Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about Atlas rocket family. So let's dive right into it. Well, first we have to understand what we are talking about. We are talking about a rocket family. We are not talking about this rocket. We are talking about a family, a series, so to say. Now, this puppy is old, as in older than space missions, so to say. So this was built in 1957. Yes, this puppy is 63 years old, as in grandpa kind of age. Now this started as a ICBM. That back then nobody wanted to build a satellite, and nobody even knew what a satellite was, so to say, like as in like a proper use case and all that jazz. So it was built as a ICBM. Now fuel wise it used RP1 and liquid oxygens. Now, the importance of this rocket to America is very high. The reason for that is this puppy was the main workhorse of Mercury project. Basically, Apollo was a project, Saturn V was the rocket, Mercury was the first of that series, so to say, to make a human mission. So Mercury was built as in like project wise, and it used Atlas. The designation was Atlas 6, and it allowed first American to go to space. So that was very, very important, and it was done in 1962. So be mindful, this is very significant for American space mission, so to say. Now, how old this puppy is, to understand that, like to comprehend the reality of it, back then they had different names, as in like SM-65 Atlas. Now, this was also US first ICBM. That's also a very integral part. Like this was like first serious ICBM. They had multiple missiles, but like ludicrously long range, this puppy was the first one. Now, American military did use this, but they are like, yeah, this is too messy. So they placed the order, so to say, as in like 1959. They were like, okay, we are ready, we can deploy this, and more orders were placed, and they retired this puppy at 1965. Now you may be like, that's a bit too early for, like, missile systems are very big, expensive. The reason for that was this was a very quote unquote fragile rocket, as in it required basically liquid oxygen, which means you cannot fuel it and keep it ready for launch. That cannot be done. Flat out, it required a missile silo with a proper fueling system where you not only can generate liquid oxygen or keep liquid oxygen for a very long time. So you can understand, it was not something, oh, put it on a truck and just go all around the country, or put it in a submarine. That was not very flexible, so to say. On top of that, that was just liquid oxygen part. The side effect was that they were using balloon rocket. You have to understand one thing: the rocket engines that we have today, they are on a whole different level. It's like the same way our mobile phone became computationally much more power efficient while computing more. Same happened with rocket engine also. Back then, rocket engines were barely able to do anything, so they had to basically reduce weight by not even painting this puppy, and to achieve even the lowest basically weight possible, they used a steel tank. Now steel sounds good. Here's the reason why they use steel: because they can make it extremely thin, and benefit, they were making a balloon. This was an actual balloon tank rocket. What does that mean? That means it was always pressurized with around 5 psi with nitrogen. So if they had to fuel it, they had to replace the nitrogen, fuel it with something. What happens if they disable the nitrogen? It will collapse, which has happened in a launch pad. They were accidentally some valve got stuck, or somebody made a false move, and the nitrogen was emptied. It collapsed and resolved. So it was a fragile system. Yes, it was an ICBM, but fragile. So US Army was like, okay, this was first gen product, let's try to make something better. So other things were created, and to handle the situation, the fact that they have unpainted steel system, they created a system to basically remove water from it, so it can be prevented from rust. That puppy, that is called WD-40, aka water displacement number 40th try. Now again, there is a lot of conspiracy, so to say, like who actually built this, and like who bought it, sold it, because again, for trade secret, they never patented it, so nobody actually knows who built this puppy. So WD-40 was used. Like, that's how old this thing is. And to understand this aspect, when rockets were this young, they did not have a proper gimbal. Right now we take, oh, gimbal is like only 10 degree from plus and minus 10 degree in both axes. That was not heard of. Like back then it was like, what gimbal, what you gonna do, move a main engine? That was not unheard of. So what they used to do is what we call vernier thrusters, basically a tiny rocket engine whose sole job was to manage the big puppy. So big puppy would be like, okay, I'm pushing it up. It's like, okay, go left. This vernier rocket would be like, okay, tilt left. Now this system, you can understand, that inherently means you have a completely independent fuel system, secondary system, just to add basically guidance on your rocket. So that's why they were not that powerful. And you can easily notice, if you watch old footage of these rockets, you will see like yellow jets coming out. Those are vernier thruster system. So it's a very old, like what we consider rocket today, like these people laid down the foundation of that. Now, after that, it was working. It was a very successful system, but Soviet Union collapsed, and Americans were like, "Okay, let's understand your rocket technology." And then one magic gem was found, which was RD-180. Now, this puppy has single turbocharger and has two nozzles. Now, mind-boggling part of that, it's a closed cycle. Closed cycle in itself is very difficult. Be mindful, America's proper closed cycle system was in space shuttle. Somehow, before that, they had a closed system with is extra cherry on top, oxygen rich pre-burner. Somehow they were doing oxygen rich pre-burner, which mind you only rocket engine doing right now is Raptor. So this was surprisingly advanced technology wise, and it was surprisingly powerful also. It was like solid rocket, so they are like, okay, we gotta use this system. So it was perfect fit for Atlas. So Atlas 3, so to say, Lockheed Martin bought this engine, like proper technology transfer happened, and they were like, okay, we're gonna use this engine, you're gonna manufacture it. One company in USA will also have the ability to manufacture it, because it's a critical system. You cannot have just like, okay, if you shut off your door, we are stuck. That will not happen. So that was a part of the agreement. So a lot of these engine RD-180s were ordered, they bought, and they are the foundation of current Atlas pipeline, so to say. If you have Atlas, any Atlas, Atlas 4, Atlas 3, Atlas 5 right now, moon mission, Mars mission, all that, they are all doing RD-180. So basically this era is called RD-180 era. Surprisingly interesting, right? Now this was used in like as early as like Mars 2020 rover, so persistence rover. So it's a very recent thing. It's like it's still being used. However, due to political conflict that happened in around 2014, US and Russia, they were like, yeah, we do not like the idea, because we think of NASA, but there is another division of USA Pentagon, so to say, that is like what we call space defense systems and all that jazz, Department of Defense and all that. They wanted a satellite launching vehicle which is completely independent. It's like, dude, we control it, this is our national security, we got this. They cannot say we got this if the freaking engine comes from somewhere else and it comes from Russia. So they were like, okay, we have to phase it out. So US Congress started restricting RD-180. So a new bidding war was started. It's like, okay, you know what American manufacturer can build an engine that can replace this puppy. The winner was BE4 from basically Blue Origin. If you're like, what the hell Blue Origin is doing, because they have not single rocket in, like, you know, proper rocket compared to SpaceX, even though they were started early on. The reason for that, like, they were competing for this puppy and they succeeded. So RD-180 in future will be replaced with BE4 engines. So this RD-180 era will end soon, around 1 or 2 years from now. But you have to understand, when you're talking about something this old, something this long, you are also talking about a lot of messy designs. Ask any of your programmer friend, they will tell you, like, they will start a code, they will start writing, oh, this issue, they will try to fix it, and they're like, do it for a few years, and they're like, dude, it's much easier to just scratch it all away and then start from fresh with a new understanding. So then same thing happened with this rocket. It was never built as a, like, okay, Saturn V, it was built for one thing. It was like, okay, we're gonna take man to the moon. This was never built. It was built as an ICBM and it was retired very quickly. It was like kind of insulting. So the core architecture was never like, okay, sit down, design it properly as a space vehicle. It was never done in that way. So a lot of iterative designs were the benefit. It got improved, refined, polished, but side effect, it had too many models, too many changes, and it, because of its so messy history, it was very, what we call, expensive to produce. Like, you can make Falcon 9, multiple Falcon 9s, which has higher payload capacity than this puppy, for a cheaper price, simply because Falcon 9 has less parts. Like, remove everything else. In engineering, complexity is the enemy of reliability. So you want to reduce your parts. Like, if somebody says, hey, this rocket has 30 engines versus this rocket has 28 engines, if you want reliability, you're going to go with 28 one, because you may think, oh, more engines to, like, you know, more failovers, but that simply means you have more messy products, which is always bad idea. So inherently, it's very expensive to produce. It's not like ULA is, like, you know, exploiting people and all that jazz. It's inherently expensive. Like solid boosters, first, not a good idea for basically non-ICBM use, and given the fact that inherently the design was not thought of like, oh, we can, you know, do without solid boosters. So they have oxygen pipe that is coming on the outside, they have electrical wiring coming on another side. Now when they realized, okay, we need more oomph out of this, they thought, okay, let's add a solid booster. But here's the, it is unsymmetric. The outside cylinder is not proper, so you cannot just mount anywhere where you want, like where you want 2 of them, 4 of them, 6 of them, so they are stuck. So that's why you see the launch, certain launches, you're like, hey, why the hell rocket is drifting? Basically it's compensating the angle. Otherwise, like, if you have unsymmetric thrust, your rocket is going to tip over. So to compensate for that tipping over, it's doing drifting, especially doing Tokyo drifting, you know, on that. So it's inherently very messy. So what we can expect in the future? Well, you have to understand that Boeing and Lockheed Martin, two giants of space industry of US companies, they got married and they created a baby known as ULA, United Launch Alliance. And ULA also has a lot of other sub companies, subcontractors that are helping them together. So ULA at this point in time is a serious force to reckon with, and they have very long road ahead. Like even with SpaceX achievements and efficiency, low cost and all that, ULA is not someone who's really, that's not going to happen. And ULA has very good ties with Department of Defense, not with NASA, with Department of Defense. So if they have to do satellite launches, SpaceX actually had to sue government to like, dude, we should also able to, have the ability to compete in that. It's like, why the heck it's happening behind closed door? So you can understand this part. ULA is not a laughing matter. It's a very serious thing. So they're not going to go disappear anytime soon. On top of that, they are realizing many of their systems, and specifically the fact that Russian engines, Atlas 5 and Delta 4 Heavy, they will be retired. The whole idea is, let's remove all this. Again, these two are like same company, multiple products, not a good idea. So the new things will be Vulcan, and Vulcan will retire the name of Atlas and Delta also. Delta, I'm not sure about that, like how will they retire it, but it could also happen. And that time the complete rocket is built from scratch. This time it's like, okay, let's try to be as clean as possible, less messy as possible, and boosters can be symmetric at this time point in time. But again, why? They may not even need it. If they have more than enough Delta V, they may not need that. And the core of that puppy is Methanol engine, basically liquid methane and liquid oxygen, which will be used in Blue Origin's engine. So they're not going to go away anytime soon. On top of that, NASA learned a very important mission from space shuttle mistake, is that you should never have only one human rated system. When space shuttle failed, flat out NASA got stuck. It's like nothing, like they had nothing at that point in time to save them. So inherently that is a very vulnerable situation. So this time they are like, even if ULA is much more expensive than SpaceX, and ULA is saying no, we can do a human rating system but it will cost 3 times more, NASA will say okay, do it. So right now NASA's main aim is they want to have SLS, which will be human rated. They want to have Falcon 9, which is already certified, tested and human rated with a human cargo, and all that testing is done. So it's like, it's ready, we are good to go. And this puppy would be third branch of that. So idea is at this point in time, like in upcoming years, NASA should have a scenario where it's like, if one goes boom, they're like, okay, we cool, we got this, we can go to ISS, we can continue our moon missions, whatever have there, they will not be affected. So this time, even with higher cost, they are like in a position where ULA is like, they're gonna have a contract. Now only project that could be cancelled is SLS at this point in time, because it's like, how many years? It's like it's becoming another James Webb. So future is solid in terms of ULA. However, the Atlas name will fade on because Vulcan. So this was my presentation on Atlas rocket family. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.